There's your 2 half reactions. And by the way, you're having your first redox quiz on Thursday. Okay? This is something you have to be able to do without hesitation. So I got 5 electrons on the top, I'm going to have 1 electron on the bottom. So what am I going to do?
Times 5.
Multiply everything by 5. Because you have to get the electrons to cancel out. Okay? That's the whole point, is that the electrons gained have to equal the electrons lost. So if all goes well when you get done with that whole thing on number 12, you should end up with, obviously, 4 washes. On number 13 on this stoic, okay, you have a strip of magnesium is dropped into solution of silver nitrate. Write the net ionic equation for this reaction. If this is wrong, everything is going to be wrong. You're going to have a strip of magnesium. How are you going to write the strip of magnesium?
Just magnesium by itself.
Just Mg. Are you going to have an oxidation state on it?
Oh, it's elementary.
So you're going to put this in a solution of silver nitrate. Are you going to worry about the nitrates?
No.
How are you going to write the silver? Why don't you put it as elemental silver?
Because it's not.
Because it's not. Okay? It's silver nitrate. It's a solution. Okay? That's why I said you have to pay attention to the state of these elements. Now, is this reaction going to take place? If it's not, then there's no point in doing the rest of it.
It does.
Why?
Because
How do you know?
there's other parts of the question.
The E naught is positive.
Get out.
How do you know that it's not? How do you know that you're not as well as positive? Okay, math. Yay for math. So here's the question. If you look at, there's 3 main metals that we use in jewelry: gold, silver, and copper. Okay? Those. Huh?
Oh, someone said lead.
Yeah, lead.
I'm more of a mercury poison type of man.
Okay. So look at this in terms of this reduction chart. If you look at this reduction chart, where's gold on this chart? Elemental gold.
I don't see
it.
Close to the bottom. I don't know.
It's at the top. I don't know where it is. It's at the top.
Oh, it's at the top.
It's at 1.6.
It's up at the top, and is it a product of this reduction chart or an oxidation? Or is it a reactant?
Reactant.
Where is gold?
Product.
Gold is a product of the reduction process. So what does that mean? Is that if you have Au3 plus, what does it really want to do?
Become AU.
It really wants to turn into gold. So what that means is, do you think it's easy to take gold on the right side and turn that into gold ions?
Oh,
Very hard.
That's why we use gold.
So
yeah, because it's pretty.
So if the EUV ends up positive, then it happens.
Well, it really wants to go in that direction as it's written.
Well, like when you're comparing the metals or whatever, like when metal.
So on the metal, the farther up it is, the more likely it is to go in that direction.
So something's on. Yeah, I got it. Yeah, you did.
I think because you got a haircut.
Yeah, that's
Wake up. Now, look at silver. Where's silver? Oh, up towards the top. Okay? Now, look way down here at the bottom. You have like potassium and you have lithium. Okay? If someone goes to you and says, hey, let's go to Colorado and let's go pan for like lithium. Let's go see if we can find lithium in its elemental form. Don't go. Why? You're not going to find it. You can find chunks of gold because it's really going to.
Hey, gravity's still working.
This isn't physics class.
Boy, that's fourth hour.
The gravity just got really weird over here. I don't know.
Oh, it wasn't the gravity part. Look.
I continue.
Anyway. So with that said.
Wait,
What?
No, put your hand down. No, you don't.
No. Remember when you like look at the periodic table and like francium is super reactive and chlorine's like one to accept it?
Yeah.
That's what this is kind of like.
Yeah.
Yo.
I just want to report
Mr.
that.
What?
I remember in Chem 2 we learned about that line on the periodic table.
Okay, you gotta get more specific.
The zigzag.
Big zigzag line, the metalloids?
Yeah.
Yeah?
What's that?
Metalloids are big because they have properties of both metals and non-metals depending on how you put it back. Okay? Like silicon is the great example of that. That's what allows electronics to work. So depending upon what you react it with, it can act as a metal, it can act as a non-metal. That's what it's called.
So it's to the left is metal, to the right is.
Yeah.
I think it.
And the ones right on that step are metal. Big Mike.
Mr. Burton, you know what
Lanthanum, actinium.
LA is?
Yeah.
Series, Michael.
Hang on. So you see, you know what actinium is? AC.
Yeah.
You know what AC is?
Lanthanum and
So
actinium
you see
series.
that like black line to the right of that?
All that's doing, because by rights, that's filling the F sublevel. Okay? So by rights, if you look on the sequence, you fill like 4s2, and then you do like 3d10, okay? Right? So here's the deal, is that once you get into filling that bottom layer, if we were to put it actually where it goes in the sequence, the periodic table would be so very, very wide. So basically what we do is we chop those out and we put them down there.
So that's what the black line is for. Okay.
They should technically be up there, but the F sub level you're filling like 14, and so that would make it so wide it's just not practical to have it that way. So we said, let's put them down there. Okay. So you're on your answers to 13. One answer on 13. There's two answers on B and C. One would make a really good GPA, and the other one would make a horrible GPA. And show me the stoic. I swear to you, I am beyond annoyed with some of your stoic, which you think constitute writing down 2/1. Okay? You are not in some lame Chem 1 class. You're running with the big dogs in an AP chemistry class. Okay? Show the calculations of the units. Okay? This is not the time. That's what. Yeah, then I'd crucify you even then if you did it. Okay? Do the stoic with the labels. All right, any questions on the lab? Going once, going twice, sold. Give that hand again. Stop the camera, please. Oh.